Determine the distance between the 2 points. When we were talking about absolute value a few modules ago, we discussed how we can cross out what they have in common. So looking at the coordinates from problem 6, they both have -2 as their x-coordinate. So then we look at their y-coordinate. They have different signs, so we have to add their absolute values together. One half plus 6.5 gives us a distance of 7. In problem 5, they both have 2, so we look at the -4 and the 7. Since their signs are different, we add them. The absolute value of -4 is 4. 4 plus 7 makes 11. In problem 3, they both have a 5 in the y-coordinate. So we look at the absolute value of -2 and the absolute value of -5. When they have the same signs, we subtract them. So I'm actually going to switch these around. 5 minus 2 would give me a distance of 3. Our distance should always come out to a positive number because we wouldn't want to say something like, oh, I measured this piece of wood with a tape measure and it came out to -3 feet. We always use a positive when we're talking about distance. This drawing is from a document called the Codex Vigara that was written around 1540 CE to show the land holding of families in Aztec villages, which were located in what's called Mexico City today. The Codex Vigara shows sketches of each landowner's fields, including measurements which were used for taxation purposes. So these are little plots of land. What do you think the symbols on the sides of the fields represent? I'm going to assume that those little marks indicate their way of measuring. It says in problem 1, consider the representation of a field. Use the information about the symbols in the representation and their meaning to answer parts A and B. What are the side lengths of this field and how do you know? Well, here on the base, we see that it is one of those little dot symbols, which represents 20. And then on the side, we have a 20, a 5, a 5, and each of those little marks is like a tally. It represents 1. So 1, 2, 3. 20 plus 5 is 25, plus 5 is 30, plus 3 would be 33 units. And it also asks, how do you know? Well, 20 plus 5 plus 5 plus 3 is equal to 33. What is the perimeter of the field? So if this is 20 and 33 and 20 and 33, to find the perimeter, we add all of those values together. (20 plus 33 is 53, plus 20 would be 73, plus 33 is 106 units. Some fields drawn in the Codex Vigara appear to be in a rectangular shape, even though the field was not rectangular. What types of quadrilaterals could the field in problem 1 represent? The field could be shaped like a rectangle or a parallelogram because both rectangles and parallelograms have two sides that are equal in length. So they might be a different shape, but their perimeter would still be the same. How many sides does this field have? And how would we find its perimeter? Let's count them. 1, 2, 3, 4, 5, 6 sides. This side would be worth 3, 4, 3. This is 25, 26, 27, 28. This is 5, 6, 7, 25, 31. So if we add all those together, that would give us the perimeter of this field. Plot points A, which is at 1, 4, B at 6, 4, and draw AB. What is the length of AB? So AB is the segment that connects those 2 points, and it is 1, 2, 3, 4, 5 units long. Plot point C at 6, -3, and draw BC. What is the length of BC? This is 1, 2, 3, 4, 5, 6, 7. Draw or plot point D at 1, -3, and draw CD. What is the length of CD? 1, 2, 3, 4, 5 units. Draw DA. And what is the length of DA? It is also 7 units. It's the same as the other side. We've created a rectangle. I'm going to leave my rectangle here, but I'm going to answer the questions regarding problems 6, 7, and 8, and then we'll bounce back and forth between these slides. What type of polygon is A, B, C, D? The shape is a rectangle. What is its perimeter? So perimeter is where we add all the sides together. 5 plus 7 is 12. 12 and 12 make 24, so the perimeter is 24 units. And then it also says, what is its area? Remember, the area of a rectangle is base times height. And 5 times 7 is 35. Area gets those units squared. It's a two-dimensional measurement. Now we're going to go back to the grid to plot the points E, F, and G. E was supposed to be at -4.5, -3. F is supposed to be at -4.5, 0. And G is supposed to be at 1, 0. Then we're going to draw in those side lengths. What are the lengths of DE, EF, and FG? Well, here we have this one is 1, 2, 3, 4, 5 and a half. And this one is 1, 2, 3, 4, 5 and a half. This one is 1, 2, 3. And this one here is 1, 2, 3. So back here, if we were to fill in question 7, we would say DE is 5.5 units. EF is 3 units. And FG is 5.5 units. The polygon A, B, C, D, E, F, G is formed by composing rectangles. What is the perimeter of the polygon? A, B, C, D, E, F, G, and what is its area? So let's go back to the grid so we can look at finding the perimeter. The perimeter is made up of these outer segments. So we have a side that is 5.5, and 5 would make 10.5 along the bottom. Here is a 7, a 5. This piece here isn't the full 7, it's 1, 2, 3, 4. Then we've got this 5.5 and a 3. When we add all of those together, we get a perimeter of 35 units. For the area, we have 2 rectangle pieces. So we'll do the base and height of this first rectangle piece. The base is 5.5, the height is 3. And then we also need this rectangle piece, which the base is 5 and the height is 7. Well, 5.5 times 3 is 15, or 16.5, and 5 times 7 is 35. So when we find the total area of those two, we get an area of 51.5 units squared. Consider this polygon. What is the perimeter of the polygon? So let's count up the dimensions for the side. Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This one is 4 wide. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 12. 1, 2, 3, 4, 5, 6, 7. This piece along the side here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then along the bottom, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. But wait, if we pay close attention here, you can see 1 on the axis is 4 boxes. So if it's 4 boxes wide, it's actually 1. You can see 1, 2, 3, 4 make it to 1. So if we had 8, that is 2 4s. and 8 is 2 4s, and 12 is 3 4s. This is 1 4 and 3 4ths, which can be rewritten as 0.75. 4 goes into 18 4 times, giving us 16. With 2 left over, that would give us a half. 4 fits into 14 3 times, which will give us 12, and 2 out of 4 is a half. And 4 fits into 19 4 times, with 3 left over, which would be 3/4 or 0.75. So for the perimeter, we need to add up all of those values. Which should be a perimeter of 22.5 units. B says write at least 2 numerical expressions for the area of the polygon. Now there are ways that we can break this shape up into multiple rectangles. The area of this first rectangle would be found by doing 4.5 times 1.75, the base and the height of this rectangle here. And then we need to combine it with the other rectangles as well. This has a base of 2, but it's 1, 2, 3, 4, 5, 6 boxes. 4 fits into 6 once, with 2 4ths left over. 2/4 is 50 cents. So 2, the base, times the height for that middle rectangle. And then the base times the height for this third rectangle. That is one possible numerical expression. Another way that we could break this up is going horizontally, turning it into 3 rectangles this way. Here this has a base of 1.75 and a height of 3. I'm going to do the second one up here because I'm running out of room. This rectangle here has a base of 1 and a height of 2. And this rectangle on the bottom has a base of 4.75, and it has a height of 1, 2, 3, 4, 5, 6. Remember, 4 fits into 6 once, with 2 4ths left over, which is 1.5. Then in part C, we actually need to calculate the area. So using that red expression, 4.5 times 1.75 is 7.875. 2 times 1.5 is 3. And 1 times 3.5 is 3.5. So we'll add all those together. And we get an area of 14.375 units squared. The vertices of a parallelogram are A, B, C, D. Our A is at 0, 7. B is at 5.5, 7. C is at 3, -4. and D is at -2.5, -4. Draw the parallelogram. We should label it A, B, C, and D. Which line segments of the parallelogram ABCD have the same length? Well, AB is the same length as DC. And AD is the same length as BC. What is the area of the parallelogram? Well, let's see. Our base is 1, 2, 3, 4, 5.5. And our height is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 5.5 for our base times 11, which is our height, gives us an area of 60.5 units squared. That is the end of lesson 5 on perimeter and area on the coordinate plane.